All right, today you're going to be working on graphing linear inequalities. If you hear any other background noise, I'm sorry, I'm recording this one from home. But anyway, so graphing linear inequalities, we've worked with several different inequalities this year. But today I just want you to focus on knowing how to graph. Tomorrow we're going to be solving these inequalities and also graphing, but today's all about just graphing. I want you guys to get comfortable with all of the components of it. But anyway, graphing a linear inequality is like graphing linear equations, similar, but there are some key differences. So step one, you must solve the inequality for y. Just once again, similar, where is that word? Oh, similar to solving an equation, but you're solving an inequality. You're going to plot the y-intercept and use the slope to plot additional points on the line. So those of you that were struggling with graphing lines, this is going to be similar to that with a little bit extra. So make sure you are paying very close attention. So first, you're going to solve the inequality for y. When you solve the inequality for y, just remember that you have to, well, you're not going to be solving today, but you flip the symbol when you divide by a negative. Flip the symbol when you divide by a negative number. Because remember, 9 out of 10 times the last step when you're solving for y is to divide by the coefficient of y. So you're going to flip that sign. So less than is going to be greater than is going to be less than. Step two, after you graph the line, there are different types of lines that you're going to have to graph. For less than or greater than, when we first looked at it, these are considered what? Open circles, right? So since these are considered open circles, when we first looked at this lesson, or when we first looked at solving inequalities, we said that they were open circles because they're not underlined, they're not included. When we're drawing the line, these are going to be dashed lines. Oops. So the line is not going to be connected. Okay. When we first worked with solving inequalities, we said that the line that's underlined, that's what fills in your bubble, and those are for closed circles. So when you have a closed inequality or a closed circle, you're going to draw a solid line or a regular line where the points are all connected. Okay. Now, the difference between another difference between graphing a regular line and graphing inequalities, there's going to be shading involved. Okay. So make sure those of you that don't typically do this in pencil, make sure you're using pencil, because there have been a lot of mistakes in the past, and I do not print extra papers. Anyway, less than. When you are thinking about where to shade, you need to think of the name of the inequality. Okay, think of the name. Okay, so the very first inequality is less than. If it is less, you would shade below the line. So if you're looking at your line, you would shade under it. Okay, the next inequality is greater. Greater means you would shade above. So if this is your line, you're going to shade everything on top of it. Okay, now less than equal to, same thing, you're going to shade below. Let's say your line is negative. This would be the bottom. And I'm also going to show you another way to tell what side is above and what side is below. Greater than or equal to, you're going to shade above. Show everything up here. Okay. The solution set of a linear inequality, notice it has a star by it, very, very important, includes the shaded area. So any points that fall in the shaded area are part of the solution. What is a solution? Solution is another word for an answer. So part of the answer is going to be anything in the shaded area and also points on a solid line, aka closed circle. Points in a dashed line are not included. Okay, so let's look at, and the way these notes are set up, they're all step by step. So try to make it a little easy on you. Okay, looking at number 1. First example, you have your inequality. You don't have to worry about solving for y today, but I'll be back for that part. It says, what kind of line? First thing you want to do is look at the inequality. Okay, so since I'm not here, I'm going to write extra notes. Look at your inequality. Here, our inequality is less than. Okay, this inequality is not underlined, so that tells us that it's going to be dashed. Less than, it's in the name, right? Since it is less, you're going to be shading below. And it says graph using the slope and the y-intercept. Well, we know that the y-intercept is -5 and the slope is -2/3. Because it is -2/3, we're going to go up to the left, right? So the first thing we're going to do is we're going to plot that -5. We're going to go up 2 boxes, left 3, end up at -3, -3, then -6, -1, 9, -9, +1. Then you go the other way. 3, -7, 6, -9. Oh. Now here's the trick to drawing a dashed line. What you want to do is just draw little hash marks in between those points, but you have to make sure that the line is not connected. There has to be visible gaps there, okay, for it to be a dashed line. Now we're going to shade below. To know what side to shade, look at the y-intercept. Look at your y-intercept. My y-intercept right now is -5. So what number would be below -5? Below -5 would be to be -6. So you would end up shading everything under here, under the line. Okay. Some of the lines tend to be more upright, so it can be a little more confusing to figure out what side to graph on. So that's why we use the y-intercept as a guide. Now test it. Step number 5, test 0, 0. Well, if I plot 0, 0, does it fall within the shaded area or on the line? No, so it is not considered a solution. It would give me, if I were to plug in those numbers, it would give me a false statement. Let's say I were to test 2, 2. 2, 2 would be right here. Once again, it's not in the shaded area. And then we have -3, -3. If I plot -3, -3, it lands right on the line, but because it is a dotted line, it is not considered a solution. And then we have, let's try -4, -5. -4, -5 lands in the middle of the shaded area, so this one is considered a solution. It is part of the answers. And we'll talk a little bit more about that tomorrow. Number 2. Okay, first thing you want to do is you want to figure out what kind of line by looking at the inequality. Well, the inequality is not underlined. When it is not underlined, that indicates that we're going to draw a dashed line. Okay, so now we move on to graph our line. Well, our y-intercept is -6, and that is the very first point that you plot. Our slope is 4, but remember we have to use it in its fraction form. So from here, we're going to go up 4, right 1. If I go up 4, right 1 from that -6, I end up at 1, -2, 2, 2, 3, 6, 4, 10. Okay. Once again, it is a dash line, so all you want to do is draw little hash marks in there. The name of the inequality is greater than. So because it is greater than, we're going to shade above. Use your y-intercept as a guide. Find the y-intercept. The y-intercept is -6. Numbers that are greater than the -6 are going to be your positive numbers. So we would end up shading this side of the line. Okay. And if we test 0, 0, if we plot the point 0, 0, it would fall within the shaded area. So yes, 0, 0 is a solution. Next one. Look at the inequality. This time the inequality is underlined. One way to remember that an underlined inequality, or when the inequality is equal to, you can think of it this way. The underlined line is a solid line. So you're going to use a regular line, solid. We start by plotting the y-intercept, which is at -4. Our slope is 3. Make sure you change it into its fraction form. So we're going to go up to the right to find additional points. If we go up 3, right 1, we end up at 1, -1, 2, 2, 3, 5, 4, 8. And the other way, -1, -7, and -3, -10. This one is a solid line, so we would connect the points normally just as we would with any other line. That is correct. Okay, fixed it. Okay. Now, what side would you shade? The name of this inequality is less than. So less than tells us that we would shade below. Use your y-intercept as a guide. Numbers below a -4 are more negative numbers, right? So you would shade this side of the line. Next one. Kind of get the idea, but we will be working with some vertical and horizontal lines, so just hang in there. Okay, next one. Look at your inequality. It is underlined, so that lets us know we're going to draw a solid line. We're going to graph a solid line. Our y-intercept is -3. Our slope is -4/5. So this one's going to go up to the left. Rise over run. Always, always rise, correct? So start at the -3. If I rise 4, left 5, I end up at 1, -5. Rise 4, left 5. I am at 5, -10. Okay, opposite of up to the left is down to the right. So down 4, right 5 is 5, -7. And that's the only other point I can draw. I can graph. Make sure you draw a solid line for this one. The name of the inequality is greater. Greater tells us we would shade above. So numbers that are higher than a -3 are there. Next one. Notice this inequality. With this inequality, you only have one variable present. Meaning you only have an x or a y. In this case, we only have an x. So whenever you only have one variable present, automatically you should be thinking that you're going to have a horizontal or vertical line. Think Hoyer bucks. Now there is an X in bucks, so this one would be a vertical line. Okay. Because the inequality is not underlined, we're going to be drawing a dashed vertical line. Now we know that the slope of a vertical line, that's the middle letter, U stands for undefined. Okay, let's graph it before we talk about the y-intercept. So you're going to draw a vertical line where x is 4. So I go to the x-axis, find the number 4, plot my point, and now I draw a dashed vertical line. Okay, now vertical lines are the only ones where you're going to be able to use that inequality as an arrow. So my inequality is greater than. If I turn it into an arrow, it's going to be pointing to the right. So you would shade the right side of the inequality. Okay, now think about this. B equals, that stands for your y-intercept. Does this graph line ever cross the y-axis? It does not. So with vertical lines, you will not have a y-intercept. Last example. Once again, we only have one variable present. There is a y in Hoy, letting us know that we are going to be graphing a horizontal line. This one is underlined, so it's going to be a solid line. The slope of a horizontal line is 0 because the O looks like a 0. And we're going to go ahead and plot a point where y is -3. Y-axis, go to the -3, put your point there, and draw a horizontal line. Make sure you extend it. Those of you that draw thin lines, extend it outside of the graph because sometimes your line blends in with the graph. I need to be able to tell where your line is. I don't want to be guessing if you drew a vertical or horizontal line. Now, this line right here is crossing the y-axis at the -3. So with this one, there is a y-intercept. The y-intercept is -3. Less than or equal to, that tells us that we shade below. Now, hopefully it's not difficult for you guys to tell what side is below this line, because this line is literally laying down. And there you go. Okay, so make sure you fill out. I know on the assignment is broken down step by step, just like shown here. Make sure you fill out each and every part because I will take points off. And you may now work on your assignment.